moving on to lab 8. Now, lab 8 is pretty cool. What we're going to do is we're actually going to use a motor, hydraulic motor, so spinning. And we're going to use a throttle valve to control the speed of the motor. We're going to look at pressures on either side of the throttle valve. And then we're actually going to use a pressure compensated throttle valve and kind of see how that affects things. And we're also going to change the pressure so we can see if changing the pressure either higher or lower is going to change the RPM of the motor. And we will see that it does, but when we use the pressure compensated, it won't. Okay, this is an easy hookup, but still, again, I've got to do my kind of basic things where I'm going to start from scratch and hook up my pressure. I still need my drain, I still need my tank for sure. In this case, there is no drain, so I don't have to worry about that. But I'll always check my circuit to make sure I don't have a drain. Okay, good. So now, I'm going to hook it up the way the flow is going. Now, in this case, we have something just maybe a little bit different in that we're not using both out ports on my DCV, but it's okay, and I'll tell you why in a second. But as far as our circuit goes, I'm going to come out of A, and we know that's A. I'm going to come out of A, and then from there, I'm going to go into my motor. So you can go into this side of the motor or that side of the motor. It's either going to rotate clockwise or counterclockwise. It's your choice. Doesn't matter. I'm going to go in this side because it's kind of more how the diagram is. I look to hook things up how I see them in the diagram. So there's a certain geometry I like to follow. And then from here, I need to actually go into a pressure gauge. And then I'm going to go into my throttle valve, and then I'm going to study the pressure on either side. So I've got a couple different options. I know that I've got this guy over here, and I'll just stick this right onto my throttle valve. Okay, good. So the throttle valve doesn't have polarity, so either or is fine. So I'm going to put that guy in there. Now, I know that I've got a line going into here from my motor. So the output of the motor is going to go into there. So I can study the pressure on this side, and you know what? I want to study the pressure on this side too, so I'll just get another one of those. All right, good. So I'll just put that guy there. Now we can see the pressure on either side. So from there, I'm going to take this guy and I'm going to go over to my flow meter so I can study the flow rate of the liquid coming out of here. Okay, good. So again, I want to have the flow going this way and out here, so that's what I'm going to do. Now, this is kind of a little different. This is where I started with. In this case, we're not using this. We're not going to be controlling this motor both ways. Although it does, it's bidirectional. We can control it both ways. But right now, I just want to run it one way because I'm only really studying how the flow rate and the pressure are kind of linked together depending on which valve I use. So in here, I'm actually going to take this. I'm just going to go straight to tank. Perfect. Now, another comment that I wanted to make before I turn this on about this motor is, it actually has its own drain. As you know, a lot of things do have drains. So this has its own drain, and actually in this lab, it's connected straight to the drain, so you don't have to hook it up. Okay, so let's make sure everything's hooked up. I have no empty connections. It looks like I've hooked it up just like this. Okay, let's turn it on and we'll see what happens. My pressure's off. Okay, this is open. Good. Let me turn this guy on. Slowly close this. I'm good. I'm going to kick this up to 250. Oh, I forgot to hook up my meter so I could study my pressure. So let's just do that quickly. The reason I notice that is because I like to study the pressure here because this guy isn't really very good or accurate. Okay, good. Go through my procedure again. I'm good. I'm going to turn this up to 250. Okay, good. So now, I want to get this at 1 gallon per minute again, so I just have to run it to see what happens. Okay, here we go. So, this thing is going to start turning once I do this. And by the way, I didn't mention this, but that's not hooked up, and it's okay, because there's a check valve in there. Even if I did turn that the other way, fluid wouldn't come out of here, it would be fine. Okay, let's turn it on. So, I'm going to turn my DCV on and we'll see my motors. It's moving really quickly and I have a really high flow rate because this is all the way open. And I see there's really no pressure on either side. There's a little bit of pressure on this side and zero pressure on that side. As I'm turning this, Watch my flow. So I'm going to turn this until I'm going to turn it clockwise. I'm throttling until I've got 1 gallon per minute. Okay, so I've got 1 gallon per minute. Look at the pressure differential. There's a really high pressure on this side, and I've got 0 pressure here. That's just seeing the tank, which is 0 pressure. Technically, it's really close to 0. Okay, good. So got some pressure on this side, pressure on that side, and my flow rate is 1. Now, I'm going to turn my pressure up to 350, and we'll see the flow rate increases, and we may see some pressures changing over here as well. Watch this. I'm going to speed this up. Okay, so now that's at 350. I do have maybe slightly more. I'm not seeing a lot different, so I'm going to go up even higher. I'm going to go all the way to my 500, and I'm definitely seeing more flow. So we can see as the pressure is increasing, the flow increases as well. And I actually can see a higher pressure on this side as well. Okay, now let's do this circuit. As opposed to putting just a standard throttle valve in, let's put a pressure compensated valve in so that as we change the pressure, you'll see the flow rate is the same. Okay, so I'm going to shut this thing down. And this is a nice quick fix. You don't have to do much here. I'm going to put this, I'm going to turn this guy off, and I'm going to go there. Now what I'm going to do is, I'm just going to take this and put it down there. Nice and simple. Okay, good. So, disconnect this guy. Put him in here. Disconnect this guy. Put him on here. Now, just to start, I'm going to have this kind of wide open. And we'll start with the motor going really quickly. And, you know, also, one of the things you can do is while you're running this, you can see that the flow rate change will actually change the speed of the motor as well. Okay, so maybe in lab we can hook it up to another system where we can actually watch digitally the RPM of the motor. We'll see that change as well. Okay, let's use this valve over here. I'll start with 250 again, and then I'll go from there. Okay, good. So my pressure is done. Okay, it's open. This guy I'm going to open slowly. Nice. I'm going to put this to 250. Good. Okay, so I'll run my motor. My flow rate's really high. I'm going to turn that so I get a flow rate of 1. So I'm throttling it in, and now I'm at 1. Okay, good. So now, again, I'm seeing higher pressure here and lower pressure here. My motor has slowed down because before the flow rate was high, the motor was going high. Now what I'm going to do is I'm going to increase the pressure, and we'll see if the flow rate changes. Okay, I'm going to increase it. And as I go up to 500, let's just see if this changes. Cool. Pressure compensated throttle valves are so cool. It's not changing the flow rate. And if we did study this digitally, and we had an RPM meter on here, we would see the speed is exactly the same as well. Cool. So that's lab 8.